All right. Welcome everyone, all 10 of you. um, so my name is Edwin Sundberg. I work at the department. I'm going to present a bit about my research area and then talk a bit about Kubernetes and orchestration, and then finally end with a little bit of how AI is sort of changing. As vague as it might sound, I think you'll learn something today. So sort of how the software engineering profession is changing. So yeah, this is again the little agenda. I think Workner posted it. All right, so you've all RESTful APIs. They are in the background of literally all the internet. Basically anything you do, any website, take Instagram for example, there's always API requests going, and they are in 99% of cases probably REST. And this format emerged because it's really easy to implement. Like, it's not a lot of semantic, what's it called, semantic overhead to think about it, because you're dealing with resources. You have your methods and all that. And yeah, this has emerged as the one you use. The big problem with all of this, though, is that we don't have a definition of a properly designed REST API. We have a lot of guidelines, but it's mostly still a manual and ad hoc process, which takes a lot of time. And if you get it wrong, no one's going to choose your API to begin with, and how are you going to maintain it? Now you sit with this API that no one really wants to use, no one really wants to maintain it because you're breaking semantics. So now you have to learn the entire system again if you want to be able to change it, which we don't want to do that. We want it to be self-explanatory. All right, so I'm going to focus on Open API, which is a contract format like WSL for describing a RESTful API on their operations, paths, basically anything you could think of. This is the most popular format for statically describing a RESTful API. But as we'll talk about, this format is still limited. You can't define all dynamic behaviors of an API in this contract. And if you could, is it really a contract at this point, or are we just making an implementation instead? So either people tend to generate this from their code base, nothing wrong with that, but as I'm gonna approach it here is you started off with writing your specification. So for example, you might write, no pens, really? There. You might start off with, let's say you have a put. Let's take a GitHub, for example. So you have repository. So slug for the organization or user, and then project. And then you have, for example, a singleton star here. So put here would say star this repository as me. And then the equivalent here would probably have delete for deleting this star or unstarring it. The reason you usually design it this way is because now it's independent. Even if you execute this, but you don't get a reply, you can execute it again because you can repeat it. It's independent. So yeah, I think that's very general about Open API. So before I continue on to our research rather, I just want to show sort of how how this bad design sort of cascades throughout your entire system if you mess something up. So here, for example, you have between payments and orders, you have some endpoints here that are wrong. You might be tunneling everything through post. You might have what's called non-plural collections. Generally just confusing. And now you're adopting these keywords, you're trying to follow the same sort of style, and now your entire sort of architecture is just thrown together. It's whack. There's no structure to it. So these clear. So if you properly do microservices with good APIs, designs, whatever, you get a lot better. It's very easy. I would say it's very hard to write it's called highly coupled microservices this way, because if you're following all semantics and doing it correctly, then it will be self-explanatory, and you will naturally find that, yeah, this resource probably belongs to this service, and go from there. What else I want to say here? And of course, REST is super lightweight compared to a lot of other formats, such as SOAP and XML, or SOAP that uses XML, which has a lot of boilerplate for basically anything you want to do. REST is lightweight. This is what we send. Maybe you have an authentication header or whatever. You send your body. You don't have a lot. You don't treat it as an RPC. You treat everything as resources, and then you operate based on that principle. And this allows everyone to sort of work on their microservice. Example, you have the authentication team. They do their thing. If they just exposed a proper interface that follows all rules and semantics, then it's going to be very easy for everyone else to adopt it, because you don't need to understand the underlying sort of ideas of the design, because it doesn't matter. You have an interface that has login or revoke session, whatever, and just follow the contracts. All right, so the research we did was, as I said, this is a big problem with very bad APIs. So we did design science, which has, or a version of design science with the 5 phases. Explicated problem with basically reviewing a lot of literature to identify some rules to begin with. It is still an opinionated area, and we'll get to that. Then we did some interviews to just kind of figure out what would you want in this sort of application. Developed it, tested it, and yeah, we basically ended up with this little program here. So it's a Python fast API backend with a lot of rules. Front end, which doesn't really matter. Then we had to build our own parser because people aren't following the spec for some reason. Oh yeah, and with this contract, it doesn't really matter how you have implemented this. For example, I have no idea what GitHub uses to implement their API, but I know based on this contract that, yeah, this looks like same design, and I can easily tell that, good choice. So either you can evaluate this on any API you've built, basically, or you can evaluate it before you even start coding if you're doing this design first sort of approach. And their engine is customized, so you can add rules, whatever, but yeah. So these are some examples of rules, and also a little bit of limitations of this just static analysis sort of field. A lot of this stuff we can check at, what should you call it, statically, at static time. But also a lot of things you can't. Even if you have a perfect contract that describes all behavior, you don't know that it actually does what it's supposed to. For example, put and delete, as I said, these should be idempotent operations. But if you use put to create a new user, I wouldn't recommend that. Now you've kind of broken this semantic. And sure, you can look at the comments and description and kind of figure out, does it appear to be idempotent? But you don't actually know, because you only have the actual spec. And then some rules, for example, e-tags, sort of a tag, if you're reading, for example, this star thing over and over and over, let's say it's massive, you can put a tag for your it's called load balancer or caching layer, that this is the content tag, or rather it's sort of, you could say it as a hash-ish, that if it changes, you know you need to refetch it, and if the e-tag hasn't changed, you need to fetch the entire element again. Another one of these things is hate to us, which is very, I don't want to say old REST principle. REST is pretty young, but it's not really adopted that much. But again, you're supposed to point to your neighbors sort of in this REST graph, or REST API, and we can't know what things do we even have in our API. Sure, we have repositories, but I don't know what are semantic relevant repositories for this abstract repository. Yeah, so I'm just gonna show this in action real quick. There it is. And you sort of just throw in your spec, and then you get a lot of violations, as I call them. So for example, one of these design principles is if you have a collection, you should generally have some sort of pagination or filtering. You should generally not bomb the user with anything they could possibly imagine. Don't just return all users. Why would you do that? Have some sort of filter argument, which is sort of what this is pointing at. Most likely this API is using some sort of filtering, but it's not in the specification, so this is what we have to deal with. Right, so our key findings of this was that we could integrate this into design reviews, CI pipelines, requirements workshop, that it's very useful that you can adapt this, because a lot of the things such as put and delete hidden content, that's pretty straightforward. But a lot of these rules are also highly opinionated. As I hinted at with the hate OAuth requirement, I don't agree with that. I don't think it serves a massive purpose. And then there are options for turning that off and so on. Future directions, we're working on evaluating this with more developers in practice, doing some A/B tests to compare how effective this sort of evaluation is compared to just developers. An experienced developer can usually look at an API and sort of tell, okay, this is sane or this is not good, and why. And this is just, sorry. So we want to compare it to, does this produce results of the same capacity, and does it produce in a, what should I say, cost-effective way? Because having a senior developer review everything, it's quite costly. If we could automate some parts of it, that's good. And you could look, and the developer could focus on the more heavily semantic and, what should you call it? Heavy mentally lifting stuff instead. Adding more rules and looking into GraphQL a little bit, since it's based on REST, but it's also not REST. It's a request from one of our interviews. Right, any questions on that, which went really fast? Comments, yeah. So OpenAPI has a sort of, they have, what do they call? They have summary field and description fields. Those are comments in that sense, but they're not code comments. So they should describe what's going on beyond the actual contract. So that's what we'll look at. And then, sure, you have all these operations, but a lot of this stuff, just looking at the operations alone isn't enough, because, for example, if you have this path, sure, we have two different operations for this path, but we want to check, is this star on the same semantic level as another rule or as another route, for example, car? Wouldn't make any sense, because what? Star and car are, sure, they're both substantive, but they're also not on the same semantic level. Another one of these semantic things is when you're going in an API, you want to go from the more general to the more specific. So you might start off with organization, DSV, and then you have vehicles. You wouldn't do vehicles and then have another path for cars. That wouldn't. Yeah. No, I mean, generally, if you have an OpenAPI spec, there's a big ecosystem around it. You can usually generate a lot of web pages describing basically everything. For example, I know there's Swagger UI. I don't have a demo ready for that, but you take the spec and it generates a mock that you can test API. There are also servers for or services for taking the spec and then building a mock server based on the contract. Doesn't do anything, but it could be useful for testing in some aspects.
Sorry for the question. So how do you define contract? What's the contract for you?
It's not contract to the extreme, I would say. It's more you have this, and and this contract might say in this, or API specification might say you can return 400, 200, and then you have which types of response bodies you have, and yeah, not a lot of pre and post conditions, which would make it more complete in that sense. It's more just generally what it's doing, what sort of output and input you can expect from it. This can be used since you're defining all possible response types. There's also a lot of usage for this for generating your client libraries. Because if you have a spec for with all your endpoints, you can sort of generate your TypeScript code, your Rust code, whatever. So you just have functions for star repository, which is then generated based on your sort of API or request handler, and then request handler and sort of the path parameters or query parameters get defined as variables or parameters for your function. And yeah, then you can interact with it in a more programmatic way than writing your HTTP requests yourself. Right, I'm gonna switch over to orchestration in Kubernetes. I'm gonna come back to this contract stuff. It's all gonna tie together, I hope. So I had some people review this the other day, and I should probably start off saying what is orchestration. It has to do with we have our microservices. Let's say we have 10 of them. Where and how are you running them? Are you doing Docker run 10 times? Most likely not. You want something to handle the rollouts and availability. So for example, if you have a physical server that goes down, you still want your app to be available. You kind of want to move that workload to another app in that case, or another physical server. So just very briefly, this only really works if you are doing microservices at all. You could do distributed monolith, but if you have a single deployable unit that you need to redo everything every time. Instead, just split your service into many smaller services, such as auth, users probably should be the same, payments. And the big win you get by doing this is you can scale everything individually. For example, let's say you're having all of a sudden 10,000 new users trying to sign up. Yeah, they're most likely not making a lot of payments right now, or hopefully they are later, sooner than later. But at the same time, you don't need to scale out the payments handling right now. You only care about, I want more authentication. So you can scale out that container. And container you can define as code and all its dependencies sort of packaged together. Yeah, and again, you can manage a monolith pretty easily, just run it. But again, if you want to scale it, managing it's crazy. You can't run 100 Docker containers and expect to check the logs of everything, figure out what I need to scale, how, why. You need some sort of tool for doing this. So one of the so here are some more arguments for orchestration, but generally you can sort of scale based on hints from your app or based on just pure resources. Kubernetes, for example, has, it's called HPA and KEDA. KEDA can be used to kind of check, okay, how many jobs do we have in the queue? If we have too many jobs in the queue, we should probably scale out the number of workers processing these jobs. HPA is more looking at, for example, CPU usage. If it spikes, for example, you have a lot of login attempts, someone is brute forcing. Yeah, now you see that service is hammered, we need to scale that one out. Again, Kubernetes also handles a lot of just containers dying, nodes dying, because that happens. If you're running one server, that one likely won't crash, or hopefully it won't, and if it does, tough out of luck. But when you're running a lot of small servers, let's take all laptops in here, all 20 of them. Most likely one of these laptops is gonna have some issue in the next year. You don't want, and when that happens, we sort of wanted to move that workload to another laptop and sort of, you say, the app should be available. We shouldn't depend on a single device being available all the time. We sort of just want to scale out, scale in as we need. Kubernetes also helps a lot with just managing all of this. Taking, for example, this auth example we had here. If the, let's see, orders here, you need to access inventory. You're not hard coding an IP address, whatever, you're referencing, I want to talk to the inventory service. You say inventory, and then it will point you to a pod, which is currently running this. Another big thing I want to highlight here with just Kubernetes and other orchestration tools such as OpenShift, if you've used it. Nope. Built upon Kubernetes is you don't care about how it happens. You sort of say, give me this pod, give me this container, give me the login service. I want 3 of them, minimum. Figure it out. So then this Kubernetes handler, or reconcile loop as it's called, it sort of looks at your configuration. It looks at what do we have in among our workers and nodes. And if it's a mismatch, it makes a plan and applies it. So you try, it's declarative, what, not how. You tell Kubernetes, yeah, I want this image orders API. It puts it out somewhere reasonable and makes it available as, in this case, no name for it, kind deployment image. Okay, this one won't be usable. But you sort of just reference it by orders API later. You don't care about where it is, what it's doing. Is it alive? Did the pod crash? You could have a new version rolling out. That messes up, but we've defined we want at least some version of this available. I think it's called, I can't remember the name of it. But yeah, and for example, if one of these sort of containers, or not containers, or pods, one of these pods die, it will kind of notice, wait, we're supposed to have 3. For example, let's say orders 1 is running on your laptop, and your laptop dies. Kubernetes is gonna realize, wait, hang on, we only have 2, we're supposed to have 3. And then we'll schedule a pod somewhere reasonable to make it available again. So yeah, I would sort of describe it as contract for infrastructure. So just as we're defining our APIs, what they should be doing, we're just defining this is what we want. Not log in here, do this. No, this is what we want, figure it out. Just some Kubernetes crash course. I'll be talking about pods. These are 1 or more containers, aka Docker images, or other types of, can't think of another containerization tool at the moment, but it's sort of the same idea. You have services, which are, this is how we get the orders, sort of, when we want to reference orders, that's a service. Which then has deployments, handles balancing, load balancing. So for example, we have 3 nodes, 2 of them die, we still have 1, it will generally route to the working node instead. You have configurations, you have namespaces, which is isolation within a single Kubernetes cluster. So you could have dev stage and production on the same cluster, but they're logically separated, so they're not going to access each other. You should probably not run everything on the same cluster, because I don't know why you're doing staging at all in that case, if you're just going to break everything. But you can use it, for example, separating concerns. I usually see using example monitoring. Put Grafana, Promtrail, Prometheus, all that under a monitoring namespace, and then put your actual app under, probably not default, but just app or something. Then you have the clusters architecture. You have the control plane, which is this sort of loop looking at what do we need to change. You have worker nodes, which are your laptops, which sort of where do we run the pods. You can run control plane and worker nodes on the same machine. You generally don't do that for security reasons, because you don't want a pod to have the possibility of accessing your control plane. And a kubectl, but we'll get to that. Then there's just some workload types. I'm not gonna bother you with the details here. 4 of them: deployment, stateful set, job, and cron job. They do basically what they sound like. Deployment is just something that doesn't need state. Your app container, your login service. The login service, the handler, that's stateless, but you probably have a database, and that will be stateful. So then you have that under a stateful set. Sample Postgres, MySQL, message queues, RabbitMQ, anything where you want to make sure that if a pod dies and comes back, we want our data somewhere sane. You have jobs, which are, they're not pods directly. They usually run one pod, but the problem with pods as they are is we don't care about them. You can create a pod, and then the pod dies, and okay, so it's a pod. We don't care about individual pods. A job makes sure that if we're running this pod, do this job, and then where we're running that crashes, well, the job will realize, wait, we're supposed to be running this, and we haven't done it, or we failed. Run it again until we get a success from it. And cron jobs are just jobs, but they're scheduled intervals, so daily backups, cleanup of all data. Yeah. So a little bit of just Kubernetes and the declarative approach I was talking about. You work with kubectl for basically anything you could think of. There are dashboards, but don't. Some commands, logs for checking your logs, obviously. Applying the manifest. Haven't shown a complete manifest here, but again, these are YAML files. They sort of look like this. Just what type of deployment, what it is, what images, and so on. Then we can apply those manifests, which then Kubernetes figures out what do we need to do. So we generally put these in files as well, because now we can put it all in Git. So we have our it's called server code, your application code, sorry. But now you also have how you're supposed to run it also versioned. You might change, for example, let's take app. You've added a Redis caching layer. Yeah, now you need to change the manifest for this, because you now need Redis as well. And now you put that in the same, probably not commit, but you sort of reference it in the same ticket, whatever. So now you know that if something breaks with deployment, you can look at, okay, what happened? What did we change? We changed this, but we didn't create Redis. We probably should have done that before deploying it to production. So version control everything. Work with it declaratively. That's sort of the main point I want to get at here. I've jumped a bit all over the place with this lecture so far. Sort of intentional. Because I want to tie it all together to how, and this is from my experience and my opinions really, how software engineering is changing a lot. So I call it Big SE. It's a word I made up all by myself, and it stands for Big Software Engineering. Uh, no more than that. So I try to look at developing as this sort of go from requirements, design it, code it, repeat, repeat, repeat. But you don't need to code it all yourself. If you can define what you want to happen, you can just delegate that to an agent, or just as a senior developer might not be coding, he might just be creating tickets and assigning developers. The important part is not how things are implemented. That's of course important, but that's not the main concern. It's more, okay, as I mentioned, now we have Postgres and we have Redis. Now we have that decision. Why do we have Redis? That's what we need to focus on. We don't need to focus on implementing the actual caching layer. That's trivial. But we do know, did realize, shit, we need a caching layer because it's too slow. So sort of, I see these days, or where we're heading, there's still a lot of work to do, and I'm not even gonna mention any tools because they might be irrelevant tomorrow. But you need to be able to define what you need to do, or what needs to be done, and scope it correctly. You can't just say, or you can say, build the entire app. It's probably gonna work-ish, but it's also not gonna work in the sense you probably want it to. It's gonna do a lot of assumption because you're not clear. You don't have a clear contract. You don't have a clear guideline for what it's supposed to follow. Okay, yeah, I should probably also define what are agents, as I keep talking about. In this term, I refer to LLM, sort of cloud code, cursor. They read files, they edit files, they can run stuff, generally, hopefully. You probably heard the terms vibe coding and agentic engineering, which is probably the more popular words for this field. But then again, your actual agents usually work with functions, for example, read file, or as I found this from OpenAI today, get horoscope. I don't know what this does. Yeah, but you sort of see how we're ending up at the same thing. We're defining, this is what I want it to do, not how or why. I feel like we're going in a circle here. I feel like, yeah, now we have contracts for what the agent can do. So why can't we use that for building our actual software as well? Then just some general heads up. It's garbage in, garbage out. You have a bad code base, it's gonna keep being bad. But if you start with a clean structure, right, the first file yourself, it'll probably follow that style. Because you wanna find, this is, I remember where I saw it. Let's say this is all code on the internet. This code is really bad. We don't want to use this code. This is the code we want to use. So we need to start off with some of this code. So the training data is using this segment of code. We don't want to use this because a lot of code is just script kiddies throwing stuff together. And sure, that works, but that's not what we want in enterprise systems where we need to be able to maintain stuff. We can't just throw it all together and hope for the best. I mean, we can. And we're going to see a lot of problems due to that. But if you want to do this in a sane way, you need to, again, break down the tasks. After example, your first agent did a draft, tell it, wait, why is this? You're just repeating yourself 10 times. Why not you have a auth middleware instead? So this is sort of where I've been hinting at, is this is what I think is so important about software engineering, because the actual source code is not really interesting. I remember a game company got hacked and they threatened to leak the source code, and they basically responded, okay, so? Because the real software engineering is, as I would put it, it's everything below. Writing source code, anyone could do that. But we can't just, all these design decisions. Why do we have Redis? How did we roll that out? If we don't have that planned, we sort of, you don't have a plan for what you're doing. You just have, just throwing stuff together. There's no general plan what you're doing. So AI is great at these bounded tasks. Make me a to-do list. Okay, to-do list for what? What framework? Why that framework? Are you using Create React App? Then AI agent might, but that's deprecated now. You shouldn't do that. And also just figuring out why we were doing stuff a certain way. An agent might look at some design decision and be like, that's stupid. But it's not thinking about that we have to deal with this legacy system that is handling data completely differently. So we kind of need to do that. Let's take this as a talked about before, tunneling everything through sort of post, whatever, instead of using put delete. Looks really bad. And AI might see, okay, that's stupid, let's rewrite that. But no, you can't, because you have an old Microsoft system probably trying that only supports SOAP or whatever. So then we need to support that. We need to figure out, we need to know why we designed something and figure out what can we change and when. As you probably realize, delegating all this implementation to agents, there's a term I read about yesterday, comprehension depth, which is now you're not following, now you're missing a lot of the iceberg. You don't know which architectural decisions were made. The AI agent did them. But you need to be aware of this, because when you're rewriting something, maybe everything depends on the step you took in the beginning. Also, another theme, for example, cross-team coordination. Or let's take, for example, the inventory system we had. Why is the inventory its own system and not part of the orders, whatever? I mean, yeah, because orders is handled by economy, has to be GDPR and financially secure, whatever. But the inventory system is just throw it together. A lot of this stuff you don't see in the source code. Sure, you might have comments, but so the real value, I think, in developers is, again, not the code, it's how we can see and like sort of wrap our heads around systems, figure out why things are a certain way, because it's not just code. There is thoughts behind a lot of this stuff. Just a little bit on contracts again. If you can follow this natural language, API contracts, if you follow this cycle, now you have really bounded tasks that AI is really good at. Example, I can give it an open API specification, implement this. It will probably implement it in a sort of sane way, because I had it generate types, and then another agent write tests. And now the agent that's actually building the actual software has really quick feedback loops. It doesn't have to think about, or it has to think about it, but if it messes something up, it will be immediately flagged. So instead of building everything and then waiting, you can sort of have incremental feedback for it. If it's heading in the wrong direction, you want to identify that as soon as possible, or you're gonna keep going down a bad path. You might continue with this code. We don't want to do that. We want to identify. We want to move the agent over here. One thing about this sort of contract first development is don't take this to the extreme. I wouldn't say writing pre-post conditions for everything is probably a waste of time. But sort of have these ideas when you're implementing stuff is sort of what I wanted to get at here. Does that make sense?
One question on this type contract. I think the current trend for like 10 years has been to move away from typing. And have you seen any change in this?
Yes, I believe so. I believe AI, you need boundaries. Because if you can identify a type violation, that's super easy to check, right? You will probably not miss a field, but an agent will immediately get feedback, wait, you're missing a field. Does that make sense?
Yeah, but it's also connected to sort of compile time or runtime.
Mm-hmm.
What you refer to is runtime, or?
No, it would be compile time, because the agent can write code that's not gonna pass linting. and it's gonna get that feedback before it has to run any tests or any of that stuff. Yeah. Yeah, again, the thing I wanted to talk about here is just, and I think I talked about it a lot last slide, have quick feedback loops, and this applies to literally anything you do. If you take a course in data mining and machine learning, they'll talk about you need quick feedback loops because that's great, especially for agents. If they can identify, even without you seeing that they're doing something wrong, you can deal with it immediately. They can keep working and then end up in the right sort of result or direction. Yeah, and I've been referring to contracts very strictly for like this sort of stuff today, but contracts can also be, I wouldn't probably call them contracts, but just requirements in general. Don't underestimate good old requirements engineering, I would say. This is just, and again, now you end up here with how much ambiguity can you deal with, and how specific you need to be. I think agents right now are really good at this sort of give them API contracts, type contracts. Maybe it will be able to figure out a lot of the more natural language stuff in the future, but as I played around with them lately, can't trust them to do that. They don't make decisions. They do what they've done. They do what they've seen before. So, just to wrap up, just some takeaways. Think about how you're designing your software, as always. A lot of it is measurable, a lot of it isn't. Think about scaling and orchestration, and also this declarative approach to your infrastructure. Try not to focus on how and where you're running it, more what you need, and then don't reinvent the wheel. Then again, the developer role is changing a lot, as I think I've hinted at good enough here. But think about sorry. Yeah, think about your your power as a human with developing. Think about you can have the mental map of the system that you could write in a markdown file, but no, you can't write everything in a markdown file, and that's just hell to maintain. Understand your system and understand why. Don't make bad code just so you can't be replaced, but have this in mind. Don't focus too much on implementations is what I wanted to get at there. And yeah, I got on quite early, so any questions? That's something really good discussion point. Agents love monoliths because they can get all context they need really quick. They don't have to search against different code bases. You have everything in the same language, everything in the same folder. It has a really easy time just searching all that and finding what it needs. And then also here you have really quick feedback loops. Because if you're changing an interface here and something breaks, you can't even compile it. The agent's gonna notice it immediately. So yeah, that's probably the thing that's talking against microservices. I still think it's a good thing, but agents don't like them. I hope they do someday, but as it is right now, no, I think there's a lot of work for them to be practically usable and to be able to delegate more to them. Yeah. So which part of it, or just? Kubernetes is orchestration framework. It lets you delegate all of the how of your deployment to the etcd and the scheduler. So you only say, you only define what you need, and you define what sort of things you have, what images they are, what they're running. You define all that, and then you let Kubernetes handle all of the which node do we put that on, how do we reach between these containers. You have your login service that most likely will need to reach some sort of database. You don't have to think about, but wait, this database is on that laptop, but I'm running here. That's Kubernetes sort of abstracts that all away. It's makes everything sort of transparent from that level of development. You only focus on what you need, and it figures out how do we reach all stuff. So.
But it's not like a integration server, right? It's more like deployment.
Yes.
So what does it do in runtime?
In runtime. So you do a lot of rolling updates, replacing this old image with a new one. Kubernetes can roll that out. It can see, oh, our error rate spiked when we switch to this version. Then it can roll back. Sorry, your other question was?
Yeah, I was thinking it's not like you said it was figuring out how to connect things. That sounds like some sort of message broker thing.
Yes. It has that as well. It has what's called gateway, which handles a lot of that stuff. One of the biggest things with Kubernetes is also the scheduling. Where do you put stuff? For example, you could define login service. You need a little bit of CPU to do the password hashing, whatever, but you probably don't need a lot of RAM. And then you can place maybe 10 of those pods on this server, and scheduling is what it's really big and good at. Scaling stuff out, figuring out where to put it. Oh yeah, networking is a big part of it, yeah. Yeah. All right, I'm gonna stop the recording, but I'm here for the next half an hour. So please come and talk about anything we talked about today.